If we know the coordinates of a point that's on the terminal side of an angle in standard position, meaning we're moving from the positive x-axis and rotating counterclockwise, if we know a coordinate that's somewhere on that terminal side, then that's enough for us to be able to find all of the trigonometric ratios associated with that angle. So in the example that we have here to get started, we've got the point 2, 3. So I'm going to go roughly over 2, 3, so a little bit higher than I am sideways, and so I'm going to draw my terminal side. So here's the angle in question. And so to create a right triangle, I'm going to drop a perpendicular down from that terminal side, make a right angle there. And so if the coordinates of this point right here are 2, 3, then that means the horizontal side of the triangle I've created is 2, and the vertical side is 3. And so now I'm ready to find the sine and cosine and tangent ratios of this angle associated with a point on that terminal side. So my sine, to find the sine ratio, I'm going to need to know what the hypotenuse is, which I can find using the Pythagorean theorem. So I've got 2 squared plus 3 squared equals the hypotenuse squared. So we've got 4 plus 9 equals h squared, or h squared equals 13. So my hypotenuse is going to be root 13. So if I label that on my diagram, now I'm ready to find these ratios. So the sine is going to be opposite over hypotenuse, so 3 over root 13. But then if I multiply the top and bottom by root 13 to rationalize that denominator, we'll get 3 root 13 over 13. For cosine, taking the same approach, we'll start off with 2, the adjacent side, over root 13. And again, if I rationalize it using the same approach, hopefully we can see that we're going to end up with 2 root 13 over 13. And then finally, tangent, we've got opposite over adjacent, so 3 over 2 is our tangent ratio. For the second example, we're going to the coordinate -6, 8. So I'm going to go left 6 from the origin, but then up 8. So we can roughly go right about there. So there's my angle in standard position. So that's my terminal side. So this is the angle theta. But in order to find the sine and cosine and tangent of that angle, I need to be able to make a right triangle. And so that's where a reference angle comes in. So I'm going to drop in a perpendicular, just like we did on the previous question. But now for my calculation of sine, cosine, and tangent, or in this case, cosecant, secant, and cotangent, I'm going to use this reference angle. And so it has all of the same properties as the angle theta. And so I'm going to label up the sides of my triangle. So just like we did before, we're going to use the x and y coordinates of the point at this location here to label up the sides. Now, normally we wouldn't say that we could have a length that is negative, but in the context of these trigonometric functions and these angles on the coordinate plane, we do use negative lengths to indicate the direction in which we're traveling. Otherwise, we wouldn't be able to distinguish between an angle whose terminal side is in, say, the second quadrant like this one, or in the first quadrant like the previous question. So we can have negative directed lengths for the legs of a triangle, but the hypotenuse will always be a positive value. So I'm -6 for the horizontal side, but I'm +8 for the vertical side. And then again, using a little Pythagorean theorem, we can go -6 squared, which is really the same as 6 squared, plus 8 squared equals my hypotenuse squared. So I've got 36 plus 8 squared is 64 equals h squared. So h squared equals 100. And so then if I take the square root of both sides, we find that the hypotenuse in this case is 10. So now that we have the 3 sides of the triangle, we can go ahead and figure out what these various trigonometric ratios are. So starting with cosecant, remember that's the reciprocal of sine. So sine is opposite over hypotenuse, so I need to go hypotenuse over opposite. So again, we're using this reference angle. So my hypotenuse is 10. My opposite of that reference angle is 8. So I can go ahead and reduce that to 5/4. For secant, so secant is going to be a adjacent over or the reciprocal of adjacent over hypotenuse, so hypotenuse over adjacent. So that's going to be 10 over -6, which reduces to -5/3. So you can see we can get negative values for these trigonometric ratios. And then finally, for cotangent, instead of tangent, which is opposite over adjacent, we're going to go adjacent over opposite. So we've got -6 over 8. And so if we reduce, we get an answer of -3/4. So for the last example, our coordinate is 7, -7. So I'm going to go to the right 7 and down 7. So draw our terminal side there. Again, remember that our angle is in standard position. That's the terminal side that contains that point. So that's our angle theta. But just like we did on the previous question, we need to use a reference angle in order to make our right triangle, for which we'll then be able to use to find the various trigonometric ratios. So I'll drop in a perpendicular here. And so now I can label up the sides of my triangle. So I've got 7 as the horizontal side here, -7 as the vertical side. And so hopefully, even though that's a -7 there, we're recognizing this as a 45, 45, 90 triangle. The two legs have the same length, even if we're declaring one as negative to indicate the direction we're traveling. So we multiply by √2 to get to the hypotenuse. So we're going to have 7 √2. And again, as I stated earlier, the hypotenuse is always positive in these types of questions. The legs can be positive or negative depending on the direction we're traveling, but the hypotenuse is always positive. So armed with this information here, now we can go ahead and find our 3 ratios. So for sine, it's going to be using, again, the reference angle here, opposite over hypotenuse. So that's going to be -7 over 7 √2. So if we do a little reducing, the 7's go, so we're ending up with -1 over √2. And so if I multiply by √2 over √2 in order to rationalize, we end up with -√2 over, and then √2 times √2 is 2. And then for cosine, we're going to do adjacent over hypotenuse. So the adjacent side is 7 over 7 √2. So hopefully we're seeing that this is setting up to be exactly the same as the previous answer, just positive rather than negative. So after rationalizing, we'll end up with √2 over 2. And then finally for tangent, we're opposite over adjacent. So our opposite is -7, our adjacent is 7. So we're going to reduce to -1. So again, these are examples of how we can find any trigonometric ratio if all we know about the angle is a point that's on its terminal side, so long as that angle is in standard position. So now let's use a calculator to see the similarity and differences between the answers for the sine of 70 degrees and cosine and tangent, and then the actual angle that we're interested in, this 250 degrees. So if we type in sine of 70, making sure that our calculator is indeed in degree mode, we're going to get an answer of 0.940. But if we type in sine of 250 degrees, even though we're using the same picture, they're in the same position, and we have this reference angle associated with it, we do get a different answer. Although the numerical answer is the same, it's now negative. And the reason is we have to indicate that the angle is in the third quadrant somehow. And the way we do that is with positive or negative signs on these ratios. And if we think about the triangle that's here that we're using, well, the x-coordinate would be negative, so that horizontal side is going to be indicated as negative, and the vertical side is negative, but our hypotenuse is going to be positive. So when we take the opposite over hypotenuse, we're going to have a negative divided by a positive, and so that's why our sine value ends up being negative. If we move to cosine, cosine of 70, if we type that into our calculator, we get positive 0.342. But if we type in cosine of 250, we again get a negative answer, but the same numerical value. So we can see that there's overlap between the 70 and 250 degree angles, but with 250, we get a negative result here because we've got a negative adjacent side over a positive hypotenuse. as opposed to if we were in the first quadrant, everything would be positive. For tangent of 70 degrees, we get a value of 2.747. And then when we type in 250, we also get positive 2.747. And that's because when we're here in this third quadrant, our opposite side is negative, but our adjacent side is also negative. When you divide up a negative by a negative, you get a positive. So it happens that angles that are in the third quadrant, like 250 degrees, end up with the exact same answer as their reference angle measures, same positive negative sign.